My name is Christina King. I'm the value stream leader for the testing solutions group here at MSI. Newer to MSI, however, I have over 25 years experience with the Crescent Design hydraulic burst leak tester, which over the years has become to be known as either the HBLT or the Crescent tester. Today, I'm going to be talking about using Pressure Manager versus, or the benefits of using Pressure Manager over the HBLT standalone. I'm also going to be talking about product characterization and using both Pressure Manager and product characterization for developing accurate, repeatable burst and leak tests with our burst leak equipment. Some of the benefits of using Pressure Manager over the HBLT standalone are speed and ease of operation, real-time graphing, increased data collection, greater testing capability, the ability to take automated compliance testing or diameter measurements, and as I mentioned, using Pressure Manager as a product characterization tool. Pressure Manager's Windows-based interface is very familiar to most users and also provides quicker data entry and operational control than using the engineering menu in the user interface on the HBLT unit. The script editor in Pressure Manager allows the user to select from several predetermined commands in order to develop scripts. It also makes sure that those commands that are available to the user are specific to the HBLT that the customer is connected to. So if we're testing with a model 1000 and our max ramp rate is 500 PSI, the operator is not going to be able to enter something higher than that so that we don't have erroneous parameters in any of our Pressure Manager scripts. The graphing features in Pressure Manager are perhaps the most useful of the tools for designing tests and for collecting data. While executing a test or a script, Pressure Manager graphs or tracks and reports the current pressure, the max pressure, and the volume as shown in the screen capture here. These graphs provide a lot of information to the user about the behavior of our products during testing. We can detect evidence of things like compliance or leaking that we wouldn't necessarily detect with the HBLT alone, which allows us to refine our tests in order to capture those events that we're looking to capture. Pressure Manager also provides custom scripting capabilities that includes volume control commands that are not available with using just the HBLT alone. The scripting language in Pressure Manager has a command for delivering volume. So whereas with the HBLT, you can only program in a ramp rate, with the use of Pressure Manager, you can deliver a volume rate. So you could do cc's per second versus PSI per second for developing a test. Pressure Manager also allows for more customizable test profiles where you have more flexibility in setting your target and your return pressures during testing. Pressure Manager can also save almost an unlimited number of tests, whereas you're limited to 40 stored tests in the HBLT. Data collection and automated compliance. So Pressure Manager offers a lot of watch windows. There are reports and logs, and it allows us to export the data for further analysis. Some of the watch windows you can see here on the right is we have the smart manifold watch window. If your system includes a smart manifold, this watch window will appear, and during testing, it will let you know which ports are selected, which are currently running the test, which are done. And then once the port is completed testing, you will see this chart fill out with the max pressure, event pressure, volumes, things like that. The test results summary window that you see on the left is just a small wrap up of the graph of the test that you've seen on a couple other screens. It lets us know the test result as well as several pressure and volume measurements. And it also allows us the user to enter in a results message. For automated compliance or diameter measurement, we offer both contact measurement, diameter measurement, and non-contact diameter measurement. In order to to take diameter measurements automatically, Pressure Manager is required. You would set up a Pressure Manager script that will allow you to take a diameter measurement reading. A read micrometer command is what we call that. Then Pressure Manager also keeps a table of the diameter measurements during testing that reports the target pressure, the actual pressure, and the micrometer reading at each step during a compliance test. All right, let's move on to product characterization and designing a test. We define product characterization as the process of trying different test settings and parameters that are going to produce the most accurate, efficient, and repeatable test results for the products that we're testing. Some things to consider with characterization are the compliance of our product. Are we testing something stretchy like a latex glove, or a rigid like a braided tube or a high pressure tube? What's our pressurization mode? Are we looking to do a straight ramp to failure? Do we want to do a staircase test? Are we doing a fatigue test? Our maintain and dwell times are important. We want to select maintain and dwell time in order to accurately and repeatably detect our leaking. What are our units of measure? The HVLT is available with PSI, atmospheres, bar, and kilopascals. And then which HVLT are we going to select to do our testing? The HVLT is available in 8 different models with pressures ranging from 25 all the way up to 5,000 PSI. And they all have different specifications. So we want to select a unit that'll allow us to go to a high enough pressure to fail our product while still providing us with enough resolution and accuracy and deliverable volume that we need for doing our testing. So let's talk about that. As I mentioned, the HVLT is available with max pressure ranging from 25 PSI all the way up to 5,000 PSI. So some of the things that we want to consider when we're selecting the right HVLT to test our product is what is the operational volume of the product being tested. The HVLT has a max deliverable volume. Each model of the HVLT has a maximum deliverable volume. In that the HVLT can fill a product pretty much indefinitely. However, once we're under pressure and we're testing the product, we have a single stroke of the cylinder to reach the max pressure and volume that it's going to take to create an event in our product. So we want to make sure when we're selecting our HVLT, we want to consider things like how compliant is our balloon, what is the operational volume, and are we attaching more than one product? Are we using a smart manifold or a manual manifold? We need to consider these things to make sure we have enough volume to do the testing that we need to do. We also need to know what's the range of pressure needed for testing. We obviously want to select a unit that goes high enough in pressure to fail our product, burst, or leak. But we also need to be careful that as we go higher in pressure range, we lose resolution and accuracy. So if we need to do some testing of products down at a lower pressure range, we might want to select a lower pressure HVLT for that type of testing. And the resolution and accuracy meets our testing requirements for detecting leaks during testing. Establishing our compliance setting. The compliance setting defines the mechanical control of the machine based on how much we expect the balloon to comply while we're pressurizing. You can see on the graph here, we've lost control of the pressure ramp, as you can see from the sawtooth on the graph. This indicates that we've set our compliance too high. And if we do that, we don't get a stable ramp to pressure, to our target pressure. If we set our compliance too low, then we get overshoot. We can use screens like this in Pressure Manager to dial in our compliance setting to make sure that we get a stable pressure ramp and that we're not overshooting. What about our, what type of testing are we going to do to establish our test base? Are we doing burst testing? With burst testing, we need to establish a ramp rate that's a flat ramp rate consistent. We don't get a sawtooth or the overshoot. And then we also want to determine our burst rate for reliable detection of the product at burst criteria. Leak testing is a little more involved. Typically, leak testing is done in a staircase fashion. So we ramp up in pressure in steps. So say 25 PSI, then 50 PSI. So when we're developing a leak test, we want to establish our interval. I mentioned dwell, maintain, and dwell as well. Once we reach a pressure step, we tend to set a dwell maintain time to allow the product to settle at that pressure. And then we move into dwell that allows us to look for an event. And this is where our leak rate and our leak dip come in. And those settings are really important for reliable detection. We often recommend that our customers create pinhole leaks in their product in order to validate their leak test settings, to attach a known bad product to the HBLT and test the leak test that we've developed so that we can see that the HBLT does in fact detect a known leaking product with the parameters that we've set. So we definitely want to use these things to refine our test settings so that we get are able to reliably ID the failure of our product. So why is product characterization is important is something I want to talk about. The consequences of not properly characterizing our product can lead to things like false events, undetected failures, test setting as parameters that aren't consistent from one HBLT to another because they're on the edge or potentially not maximized. If our products are not being tested in a repeatable way, this can call into question the quality of the product, which could lead to product recalls. So I have this sample here on the screen of a customer that reached out to us that was having some issues with false detection as well as not repeatable results. So we brought the product in, we did some testing. The screen with no product characterization, the compliance was set too high, which caused the ramp rate to become increasingly unstable. The burst and leak detection parameters were purposely set low to ignore the instability of the ramp in order to reach the target pressure. And this caused the customer, as I mentioned, to experience undetected failures as well as not get consistent results from one HBLT to another, one test site to another. They reached out to us for help and we got their product in. With the use of Pressure Manager and trying different burst and leak criteria and different compliance settings, we were able to dial in the correct settings to achieve the graph that you see here on the right, which shows that the ramp rate is stable and we were able to achieve repeatable and reliable results. Pressure Manager is a great tool for doing product characterization because it allows us to see the volume and pressure traces in real time, and we can create sensitive enough settings that give us enough data so that we can dial in our settings and create a repeatable and reliable test. Just to bring everything full circle, I want to reiterate that Pressure Manager provides ease of operation, real-time graphing, increased data collection, greater testing capability, the ability to take automatic diameter measurements, and the ability to create repeatable and reliable tests through the product characterization. I welcome you to request a demo version of Pressure Manager to try. It's a great tool, as I mentioned, especially in the R&D environment. We welcome you to visit our testing lab or send samples for feasibility testing or product characterization services. You can get in touch with us at sales@machinesolutions.com or visit our website at machinesolutions.com. Thank you so much for your time today. I appreciate it.